Hello students, in lesson number 3, metals and non-metals. Today we are going to learn about the extraction of metals with high reactivity. The metals in the reactivity series, the top of the series like sodium, potassium, calcium, magnesium and aluminium. These metals are having a high reactivity. So high reactive metals are generally of the form of oxides in the nature. And so this metals are and the attraction of these metals with the oxygen, okay, these metals are in oxide form, so to remove this oxygen from metal oxide is quite tough. In the earlier section we have seen that to remove the oxygen we are using carbon and some other high reactive metal like aluminium, etc. But simply the oxide of this metal reaction with carbon doesn't remove the carbon, doesn't reduce the metal oxide, right? So to remove the oxygen from metal oxide with high reactivity is not easy. Okay, it's not possible because this high reactive metal have very high attraction towards the oxygen. Okay, so to remove the oxygen with carbon is not possible here. So by the chemical reduction, okay, the reduction through carbon is called the chemical reduction. But here chemical reduction is not possible for this. So we need to use some other method. So that is the electrolytic reduction. By the electrolysis process, the metals are reduced. Okay. So by the electrolytic reduction process, the high reactive metals are reduced. One example, let us take NaCl. See, sodium are the common salt for sodium is sodium chloride. So from this sodium chloride, how the metal is extracted. So this is the electrolytic cell in which there is a beaker and inside the beaker there is NaCl. And remember there is a NaCl in molten state. Okay, so NaCl is melted and that molten state liquid NaCl is taken and the two electrode, one represents the positive electrode and one is the negative electrode. So what happens when the switch is on for this electrolytic cell? This electrode will be the positive electrode and this electrode will become the negative electrode. And in a molten, due to this effect of current, due to these two electrodes, positive and negative, the NaCl molecule will be separated. Okay, the ions from NaCl molecule will be separated. So NaCl bond will be broken and Na plus and Cl minus will be separated. So this sodium plus and Cl minus will be attracted towards the respective electrode. Na plus will attracted towards the negative electrode and chlorine minus will be attracted towards negative electrode. Positive electrode. So what happens at these two electrodes? At cathode, that is at negative electrode, what reaction happens? When Na plus reaches to this negative electron have excess electrons as electrons are negative. So Na plus will get one electron and becomes sodium neutral atom, sodium solid atom. And at anode, what happens? That means at the positive electrode, what happens? Chlorine negative ions will be reaching to this electrode. So as it is positive, it attracts the electron. So these extra electrons in the chlorine atom will be removed. So chlorine negative ion will become chlorine neutral atom. So negative means extra electron it has. Okay. So this one electron extra from the chlorine ion will be removed. So two chlorine ion will give two electron and that two chlorine atom will be attached and making Cl2. So Cl2 gas will be released. So this is how at cathode the sodium atom, deposition of sodium metal will be there at the cathode. Okay. So this is how the metals with high reactivity can be extracted by the electrolytic reduction. So see, aluminium is on of the form aluminium oxide in the nature. Right? So this aluminium oxide, we have to melt that aluminium oxide and then electrolytic reduction can be done. But the problem is that aluminum oxide, melting point of aluminum oxide is very high. Okay? So this problem, so this reduction, because the metal compound should be in a molten state here in the as a solution. So to make it this aluminum oxide in liquid state was quite tough because the melting point is very high. So to resolve this problem with aluminum oxide, some other chemicals are added. Some other very specific two chemicals are added which lowers the melting point of aluminum oxide. Okay? So by so if the melting point is quite low, then it will be easy to melt the aluminum oxide and then electrolytic reduction can be done. So this is how this is a simple reaction which shows the electrolytic reduction for the high reactive metals. Okay. Now, refining of metals, the last step. The metals obtained in any of the reaction, right? That in any of the method here, that metal is not 100% pure. If we want to get 100% pure metal, then we have to refine the metal, which gives the 100% pure metal. See, if the process extraction is by the electrolytic process, then this metal will be almost pure. That means 99.9% pure metal will be obtained by the electrolytic process. Okay. So here sodium, or if we get the aluminum, that metals are 100%, 99.9% pure. But if we have obtained the metals by chemical reduction or any of the other method, then we have to refine the metal. So mostly the refining process is done by the electrolysis process. So this will be the electrolytic refining. Again, this is a simple electrolytic cell to refine the metal. Remember, the metal which we want to refine, that metal solution, that metal salt solution will be taken as a solution. So let us take one example. We want copper metal, pure copper metal. So we are taking copper sulfate solution, CuSO4 solution, and it will be quite acidified. Okay, so slightly acidic copper sulfate solution will be taken as a solution. Okay. If you want to take, want to refine mercury, then mercury salt solution can be taken. Or if you want to want to refine zinc metal, then zinc salt solution can be taken. Okay, so that is a condition that to refine the same metal salt solution can be taken as a solution here. Now, at anode, remember metals tends to become positive. So the metal will be attracted towards negative electrode. So at positive electrode, we are taking the impure metal electrode. Okay, whatever sample or piece we want to make pure, that impure rod can be taken as the positive electrode, and at negative electrode anything can be taken, like if we have the pure copper plate, then that also we can take. So pure metal will be taken as negative and impure metal can be taken as positive electrode, and the solution is the copper sulfate solution. Now what happens in a solution form? We know that in a solution copper sulfate will be dissociated by the water. So copper sulfate will be of the form copper plus 2 and SO4 2 minus. As the switch is on, these two ions will be attracted towards the respective electrode. Copper plus 2 will be attracted towards the negative electrode and SO4 will be attracted towards positive electrode. So what happens at cathode? Copper plus 2 will reach to cathode, negative will gain 2 electrons because negative have extra electrons. So copper plus 2 gain 2 electrons and making copper solid. So copper solid atom will be deposited on negative cathode negative electrodes. So imagine here all these copper atoms, copper ions, copper plus 2 ions from the solution are attracted towards negative electrode. So all the copper atoms will be deposited on this cathode. So there will be a lake of copper ions in the solution, only SO4 2 minus will be remaining. So to fulfill this shortage of copper plus 2, the copper present in this impure anode will be coming into the solution. Okay. So what happens at anode? The copper solid atom will release two electrons, and that two electron will be attracted towards the positive in the battery. Okay. Electrons are moving in a wire towards positive side. Okay. So at the positive pole of the battery, the electrons will be attracted. So copper atom will release two electron and making release two electrons. So by removing the two electrons, copper will become copper plus 2, and that copper plus 2 will be coming in the solution. Okay. So basically what happens? The copper atoms from the anode part, anode electron will be coming to the solution, and from the solution the copper plus 2 atoms are depositing on the cathode as copper solid. So ultimately we can say that the copper from anode going to cathode. So ultimately the whole overall process can be written as copper solid impure giving copper pure. Okay? Because only we can say that only copper particle will be attracted towards this cathode. So atom by atom, copper atom will be deposited. So 100% pure atom. There is not any other kind of atom will be present on this cathode. So 100% pure copper metal can be obtained. And the remaining impurities will be insoluble in the solution, and that will be deposited at the bottom of the beaker. That will be the, we can say that anodic mud, it will be called. So that will be removed afterwards. So overall, at the cathode, the metal can be obtained. 100% pure metal can be obtained. So read up to this, and still if you have any doubt, you can ask me. Thank you.